Okay, now let's proceed to the lesson 4, the nano world. So, kaning lesson is nag-introduce siya sa nanotechnology and advancements with dealing with kaning extremely small materials and structures. So, we have the lesson objectives. At the end of this lesson, students should be able to first define the nanotechnology. Second, characterize nanoscale. 3, describe the uses of nanotechnology. 4, discuss concern about nanotechnology. And the 5th is explain the status of nanotechnology in the Philippines. Next. So let's have the introduction. So, scientific researchers develop technology tools that improve life. Nanoscales is an interdisciplinary area produced by advances in science and technology. Scientists build materials with new properties and manipulating nanomaterials. These have implications in healthcare, environment, energy, food, water, and agriculture. So, nanotechnology began because of scientists discovered how to manipulate matters at very tiny scales. So, kani siya is gagmad kay sila. Like ano siya, like small atoms and molecules. So, for example, ani is kaning kaning sa gold nanoparticles. Ang normal color sa gold is yellow. So when pag-abot sa nano size niya, ang gold particles niya may mo siyang red or dili purple. Kaya nga naman, because the electrons behave differently at nanoscales. So ano siya? Next. So, next is what is nanotechnology? Nanotechnology is equal to science, engineering, and technology at the nanoscales 1 to 100 nanometers. Nanoscience uses exceptionally small things in materials, science, engineering, physics, biology, and chemistry. So, ito siya guys. Wala yung nawong. Wala siya ang nanotechnology. Next. So, we have the history of nanotechnology. In 1959, Richard Feynman proposed controlling atoms and molecules, named plenty of rooms at the bottom. So, the term nanotechnology coined by Norio Taniguchi in 1970s. So, how small is nanoscales? So, a nanometer is equal to 1 billionth of meters. Nanoscales materials are extremely small compared to everyday objects. So, as you can see, nakay kanito ko. So, atong wait lang. So, the example here is kanina itong human fingernails. So, ang fingernails daw na case, nag-grow siya about 1 nanometer per second. So, inana kagamay ang nanoscale. Gagmay jud kasi so kung sa other example po kung sa buhok daw ang ano na to kaning ang human hair na to is nag-view at like ang single stranded strand dito sa tong buhok is one siya of about 80,000 to 100 nanometers wide. Ano siya? So next, types of nanomaterials. So nanomaterials vary shape and sizes. So we have particles, tubes, wires, films, plates, and shells. They do have no more nanoscale dimensions. So yan siya. Ano yung mga kurba guys? As you can see, daghan kayo. So kasi ng mga pan, nasa yung mga dimensionality. Next. So viewing nanomaterials. So, there are mga special microscopes are used to see nano-objects and nanoscale objects. So we have the electron microscopes, field microscopes, tunneling microscopes, and atomic force microscope. So kaning first nga one ang electron microscope, and then kaning sa PDTI is atomic force microscope, and then ang kaning ikatulo is ang field microscope. microscope, and then kani ang tunneling microscope. Next, so we have the electron microscope. Explain na to. So, ang electron microscope now is developed by Ernst Ruska and Max Knoll in 1930s. So, uses electron spins to magnify specimens. So, higher resolutions up to 1 million times magnification, types of CEM and TEM. Next, we have the atomic force microscope, or AFM, developed by Benny Cole and Gerber in 1986. Uses of mechanical probe to collect surface information. Next, we have the scanning tunneling microscope, or STM, allows scientists to view and manipulate nanoscale particles, atoms, and molecules. Inventors Binig or Binig, Norer, and received the 86 Nobel Prize. Next, we have the nano manufacturing. Scaled up, reliable, cost-effective production, nanoscale materials devices systems includes improvement and integration processes. So, wait lang. So, manufacturing turns a lab discoveries into a real products. So, this bill ensures that nanotechnology applications can be mass-produced and affordable and safely. Next, we have the two approaches. Excuse sa bottom up na siya, bottom up and top down. Okay, next. We have the bottom up. Bottom up means build products from atoms or molecules upward. Time-consuming research continues to improving self-assembly techniques. So, ano siya? Bottom up is nag-approach sa self-assembly. So, yan ay yung forma. And then, ang top-down fabrication is, top-down starts with a large material stream, then to nanoscales uses more materials and creates waste. So, yun siya ang forma. Approach, build, in, place. Ano yung commercial setting sa food. Wow. Now, let's have the modern fabrication methods. So, we have 8 methods. So, deep pen lithography. Yan siya, ang katong sa taas ng brush sharpening, nakalight na mga ball pen na yan. Tapos, ang next case, self-assembly. Siya na siya ng process sa taas. And then, chemical vapor deposition. Yan na siya, and then, nano